Hello everyone and welcome back. So in this video, instead of doing my regular kind of upload schedule where I would just upload a Python tutorial, I'm going to be showing you guys this small project I've been working on for about a few days now, and I finally finished it. So what this project essentially is, it's a snake game, and I'll go into I'm just going to be showing you guys how I built the snake game. And just so you know, before, like a heads up before I go into the rest of the tutorial, this is my first time dabbling into things like Pygame, so I probably made a bunch of mistakes, or well, I could have made the code a lot better, but this is essentially the way I approached it, and I actually got a result I'm pretty happy with. So I'm just going to show you a preview of how this game actually looks like in action. And I coded this thing out in Sublime Text, if you're wondering. So it's essentially a grid, and then this red character here, right here, that's your snake, and then the green here block here is the food, and then you can move your snake around the grid, and then when you touch the food, your snake gets longer, and then as you can see, it just keeps on getting longer. Then you can kill your snake if you want. If I could kill myself, okay, I killed myself there. And it will show the small pop-up window, and then I'll show you guys how I built that thing out, and then it shows you a score, which is going to be, in my case, I got 3 since I ate the food 3 times. I'm just going to quickly say something that this video is completely unscripted, so I don't have any notes prepared for this thing at all. So it's going to be going through the entire code base and showing you guys how I did everything. So first off, right here, here I'm just importing all the different modules I need. So first off, I need Pygame, so we can actually use Pygame. So if you don't know what Pygame is, it's simply a it's pretty easy and intuitive module you can use module in Python, which you can use to make small and simple 2D games. So if you don't know how to install Pygame, because it does not come with Python pre-installed, so it's going to open up your terminal. In this case, I'm using PowerShell. You can open up your command line. You can open up git bash, I think. I doubt it'll work in here. But you're going to run pip install Pygame, if I type that right. And then you should get this. If you're on Mac, you can do pip 3 install Pygame. And then for your Linux distributions, it will depend. Usually, if you're on Debian or Ubuntu, you're going to do sudo apt install python 3, and then you're going to run sudo apt install python 3-pip to get pip 3. So you can actually use the Python package manager. Then you can do sudo apt install python 3-pygame. If you're on Fedora and your RHEL-based distribution, sudo dnf install python, and then it's going to repeat those same steps which you did before for Debian, but instead you're just going to replace the package manager with, instead of being apt, you're going to use DNF, because that's what nowadays RHEL's using. You can also use yum, I believe, but I think it's been replaced with DNF now. I'm not really sure. For Arch, it's going to be sudo pacman-s python. Then you're going to do sudo pacman-s python 3, sorry, python-pip. Then you're going to do sudo pacman-s python-pygame. And it's going to be different for OpenSUSE. It's going to replace with Zipper, and yeah, you can just search out the packages. In the link description in the video below, I'm going to give you guys a link to my GitHub repository, which contains the entire code. And then in the README file, you can see instructions on how to install Pygame and set this thing up, so you can actually use it on whatever operating system or Linux distribution you are using. Okay, so let's get on with the rest of it. So sys, I'm going to be using that in order to I'll show you guys later that thing later. Random, I'm going to be using that to get random positions for the food. So if I show you guys right here, let's go get the food. The food will spawn random locations across the grid, and yeah, I managed to kill myself there. Okay, then we're going to be using tkinter, and the reason I'm going to tkinter is I need to import 2 libraries for that. So if you don't know, tkinter is essentially like a library which you can use to build graphical user interfaces inside of Python. It's not really that robust. It's not as good. It's kind of old, but it's useful for showing or displaying messages. So let me cue myself here. So this game over screen, right? You see right here, it's saying screen score 0. That's from tkinter. So we're going to be importing everything from tkinter, then we're going to be using tkinter, the message box method instead of tkinter. You might have noticed, if you guys are fans of another YouTuber called Tech with Tim, he's very popular. This game looks kind of similar to his in a way, because I tried to make the game look similar to his, but if you actually look at the code base between both these projects, they're pretty much completely different. So I approached it in a different way. And this entire thing I tried to keep it object oriented. This is really my first time dabbling in. Actually, I learned a lot about how object oriented programming works inside of Python, just by doing this project. So without further ado, let's just get into the rest of the video. So first off, I created this class called main, and then I made this in underscore init dunder method. So as soon as I make an instance of this class, or one of the child classes, because I'm going to be inheriting all the attributes and methods from in this class into other classes. I'll show you guys that later in the video. I'll be able to I have to all these so as soon as you make an instance of this class, all these attributes you can inherit into the class by inheriting the underscore init method. So first I'm just going to finding a few attributes. So these instance attributes. So the first is going to be self.width. So this is the width of the screen. I set it to 600 pixels. You can change it to whatever you want. I recommend that you keep it 600 pixels because, I'll just show you guys, if you change it around, the grid kind of starts messing up. The game does work, but it's not really that functional. Yeah, it does. The game does work, but it's not really that good. Then we've got a score. So we're going to be using this to keep track of the score inside of this game. And then we're going to have some information about the rectangle. So the rectangle x coordinate is going to be 0, and then the rectangle y coordinate is going to be 0. Then the rectangle width is going to be set to 0, and the height is going to be set to 0. So if you're not sure with Pygame, this right here is actually a rectangle. I know it looks like a square, but in Pygame is actually a rectangle. And then we're going to use this in order to actually draw our character and the food, and then we're going to be using lines to draw the grid. And then I'm going to finding a few colors here. So in Pygame we use Rgb Colors. So that stands for red, green, and blue. So the colors I'm using this game is going to be black, red, white, and green. So black is for the background, white is for the grid lines right here. Then red is for the player. Then green is for the food there. Let me quickly go up here. Then I will just return this back into 600, so it's the right resolution. Okay, now it works. Okay. Then so black is 000, red is 255, 0, 0. White is 255 for everything, and green is 02550. You can search this up on the internet. Just search up RGB Colors for these different ones, and you'll be able to find it pretty quickly. Then some other stuff right here. So we're setting our screen, which is going to be using this method called pygame.display.setMode, and then this accepts two parameters inside of a tuple, and that's going to be the width and height of our screen. I set these both to be the width, so this is both going to be 600 pixels by 600 pixels, so it's a perfect square. It just makes things easier when I'm drawing the grid, since everything is both of the height and the width is exactly the same. Then I set the screen caption. So right here, as you can see on the top of the screen, we've got Snake Game, and that basically is the screen caption there. And then I set the screen caption to Snake Game, and then I for some reason I set the score here again. I don't know why I did that. Okay, it looks like I made a mistake there. So the clock is so the game clock is going to allow us to keep track of the movements happening in the game, and I just mainly use this to set the FPS of the game, which is frames per second. So the way games work is that I'll just draw something right here. Okie dokie. Oops, this is from the last lesson. I don't have my drawing tablet with me, so I'm just going to do a rough sketch of how this works. So in Pygame, in games in general, the way it works is that we have something called a display surface, and the display surface is essentially just what we call the screen. So here where I said self.screen is equal to pygame.display blah blah blah, that's what we call our display surface. And on this we can draw things onto the screen. So the things that you draw onto the screen are called surfaces. So let's just draw a few shapes here so I can illustrate this to you guys. Okay. So right here I've got a circle and I've got a square. Now these two are what we call surfaces, and we can draw this onto the screen because this is how. So the way it will work is we've got a display surface, and we can put surfaces on top of our display surface, and we can blit that onto the screen using a method called blit, or we can draw it onto the screen if we're drawing like things like rectangles, which are built into Pygame. So what we can do is, if you see so whenever we try to make our characters move, what we are actually doing instead of moving our characters is that we are actually just updating the screen. So our FPS stands for frames per second, so it basically means how many times we refresh our screen per second. And so let's just say we refresh our screen 10 times per second. So every single new frame, every single second, our screen's going to be updating 5 times. Sorry, 10 times if our FPS is 10. So in that case, if our character is moving 5 pixels to the right, if the FPS is high enough, it will give us the illusion that our character is actually moving the game, when in fact we're just redrawing the screen every single time and the surfaces are just moving places. Also, we can make the surfaces bigger and smaller. So if you ever see like a giant background, so let's just say we have a background in our game, that's actually just one big surface taking up the entire display surface. The display surface is going to be behind. It's going to be behind all of the surfaces, so we can draw things on top of them. Okay, so I explained that to you guys. So this clock, this instance that we made of the pygame.time.clock, this clock object will allow us to set the FPS of a game and do a lot more things, like keep track of all the movements, but I didn't really use it for that. Then I created this method called update, and this is just updating the screen. So pygame.display.update. I believe you can also do pygame.display.flip, which basically does the exact same thing, but is just is more reliable, I believe. So pygame.display.update, I just believe is a bit lighter or something like that. They're both the same thing. I think flip is more effective, but it refreshes the whole screen. Yeah, that's what I remember about it. So update, I think pygame.display.flip updates the entire screen, and update does a little bit less than that. They're both the same thing, so essentially they're the same. They do exactly the same thing, so it doesn't really matter. So clock.tick here. So this clock, this instance I made of the clock object here up here, I reference to it here, and then I set this tick. This tick method allows me to set the FPS. And it takes in a parameter, and then that's going to be an integer, which is going to be FPS. So I set this to 10. You guys can set this to whatever you want. I don't recommend doing it too much, because then this makes the game harder since the snake moves faster. So if I made this thing like 60 FPS, yeah, this game is essentially impossible to play. So I recommend keeping it around 10ish or 15. I don't recommend going higher than that. For other games, it doesn't really. For other games, like the higher FPS you get, better is, because the game looks more fluid. For retro arcade games, like which are 2D, such as Snake, it kind of works the opposite way. It makes the game a bit harder. So draw grid. This is what I'm using to draw the grid, and it takes in 3 parameters. There's going to be the screen width, the box size, and then the display surface. So I'm going to explain this. So the screen width is essentially this thing right here, which is the width of our screen. I set it to 600 pixels, so we're going to be taking that in. I could have referenced that thing directly, but then but then I decided just to do it this way, since it'll be easy. I can show you guys how we can accept parameters into methods. It's pretty similar to like a regular function. So we can so this box size is essentially the number of boxes you want on the screen. So in this case, I've got this is going to be 30 by 30 boxes, and this is why it's useful to draw this entire screen as a square. So if this is 30 boxes on the top, this will also be 30 boxes on the right, since the exact same length. Okay. So I set that to 30. So if you guys wanted to change that to 40 or something, you can do that if you wanted to. Then we've got display surface, which is essentially our display surface, and in this case it's going to be this screen attribute I've defined right here. Okay, So here I created an instance attribute called self.mbox, and this is basically the distance between each of the boxes. And the way we calculated this is, if I pull this down here, I use this double forward slash operator, which essentially divides these whatever values these two are, and then returns to us as an integer instead of giving it to us as a decimal. So if I just unlock a single slash here, then we quickly just quit out the game. Okay, so if I just unlock a single slash, this will give me a decimal, but I don't want a decimal because we can't really pass that into our function. It just makes things harder. So we're just going to, I set this to be a double forward slash, which essentially just divides and then gets rid of the decimals at the end. I believe it also rounds it up to the nearest whole number. But if you didn't want to do that, you can just do int self.nbox, which will just cast it to an integer, and then we'll do self.n_box. It's going to be, if I can type right, it's going to be that. Okay, so that's the way you can do it. So this is self.nbox is a distance between the boxes, and the reason I put this as the reason I made this an instance attribute is because this will allow me to reference to it later, which will later in child classes and outside of the function. Sorry, outside of the class. Once I made an instance of it, then I set x and y, and this is essentially going to be the starting positions and the ending positions of the lines. So if you don't actually know, I actually used a for loop to loop through the self.nbox and then draw these lines. So this grid is basically a collection of lines. That's all it is. And so to do that, I did for I in range of box size. So over here I did box size, so it's 30. So for I in the range of 30, so when this for loop loops through it, I is going to be set to a number instead of 30. So when starting off is going to be starting off as 1, then it's going to be 2, then 3, then 4, then 5, and then it'll go up to 29 instead of 30, because that's the way range works. It's going to be so if I explain how this works, range accepts two values. So it's going to be the start, except three values: the start, the end, and the step. Now the start, if you don't define it, it's going to automatically start at 1, and then the end you can define it to be whatever you want, but it's going to be 1 and then the end inclusive. So it won't actually include the end; it will include one integer behind the end. So that's the way it works. So we're going to set x is equal to x plus self.nbox and y is equal to y plus self.nbox. So we are essentially just doing here is that we are just setting the x variable equal to self.nbox every single time. So this is essentially exactly the same as if I did x is equal to plus equals to self.nbox, which essentially means that I am adding the value of self.nbox onto the value of x every single time I loop through it. Now, why would I want to do that? So if you actually look at this this grid, the way Pygame works is that we're going to have our x and y is going to be working like this. So we're going to have x here, and then we're going to have y, if I can write down. Okay, that doesn't really look like a y, but again. And then our point of origin is going to be here. So this is where 0, 0 is. I'm sorry, I don't have my drawing tablet with me right now, so you're gonna have to deal with this for now. Okay, so oops, sorry. This is going to be our y-axis, and then this is going to be our x-axis. I made a bit of a mistake there. Let me just quickly rub this thing out here. Oops, wrong one. Okay, so as you can see inside of this example here, I am looping through. Should probably turn this thing off. Actually, no, sorry. I should leave it here. So every single time I'm going through this for loop, it's going to change the value. It's going to append the value of self.nbox onto x. So at the start of it, it's going to be 0, 0. So I'll show you guys how I draw the lines, but this should kind of make sense if I explain it right now. So at the start, x and y is going to be 0, 0. Then in the second time this for loop iterates, so every single time this for loop actually runs, it's going to set the value of x and y, then it's going to draw the line. So right now x and y are 0, 0, so it's right here. So it didn't actually draw any lines yet because it already changed the value of x into this thing. So the value of x and y is 20, 20. 20, 20. And then the second value is going to be what looks like I need to explain this a bit better then. So the way it's going to work is here it's going to be 20, 20, then it's going to be 40, 40, then it's going to be 60, 60, and it's going to keep on doing that, and then we will end up having this even grid because 600 is an even number. If it's an odd number, it will look kind of different. Hopefully you guys can wrap your head around how this works. So essentially just going to be drawing lines at an even number every single time, which is going to be the distance between each of the squares. That's what self.mbox is essentially the distance between each of the squares. Okie dokie, now we can move on to this part where we're actually drawing the lines. So we're drawing the lines and then we're giving a display surface, which is going to be self.screen. I actually pass this parameter in when I actually am calling this method later in the child classes because we're doing multiple inheritance. So I got multiple classes in this one. So I got this main class which is general things I need for the game, then I got a food class and a snake class to draw the food and snake and add some extra functionalities to it. Okay, so here I don't really want to go too in depth with how this works because this will probably make the video a bit longer than I hope it would be. So 0, y and then self.width, y. So what I'm essentially doing, if I run this game a bit again, okay, so here we're setting x to 0, so here, and then we're setting y to 20. So it's going to be starting at 0, and then it's going to be doing it here, and then x is going to be 600 in the second one. So this is the way we're drawing a line. It's going to be we're going to start position and an end position, and then here I'm setting the start position to be 0. So this 0 right here, x is going to be 0, and then y is going to be 20. So the start of the line is right here, and then the end of the line is going to be self.width, y. So y is going to be 20, so it's going to be ending at 20, and then self.width is 600, so it's going to be ending at 600. And then we're going to be changing the value of x and y every single time we run this for loop, so it's going to draw horizontal lines like this, and then this other one right here handles the vertical lines. So I'll let you guys just look at the code, and it should be kind of self-explanatory. I don't want to really go into the weeds of how it works. It's pretty simple once you take a good look, once you try to understand it a bit more. Then I call this function called redraw_grid, and here I essentially just do self.screen.fill. So this display surface I was talking about earlier, right here, which is our self.screen, this instance attribute. I'm just going to set the color to be black, and then I'm going to be calling this draw grid method, which is essentially going to take in 3 parameters, as I said before, which is going to be the width, so it's going to be self.width, then the box size, which I want to be 30, and then it's going to be the display surface, which is going to be self.screen. You can change this box size if you want, so if you wanted like 40 boxes by 40 boxes or 10 boxes by 10 boxes, you can change that. I'll just show you guys this, how it would look like. Okay, that kind of did not work, so let's just change this to be 60 boxes by 60 boxes. So if I change like that, it's going to be really, really small like this. And you guys might like it, but personally, I don't really like it. I think that 30 by 30 is a pretty decent number. And make sure this number is even, because if it's an odd number, it won't divide evenly, and you're kind of like this weird kind of looking generation for the food. So make sure you keep it to an make sure you try to keep it to an even number. It doesn't really have to be that one. But essentially that's how I drew the grid. Next you can move on to this one, which is quit. And here I'm going to be showing you guys how I made this this box right here, so game over. So I used tkinter for that. So I made an instance of tkinter, then I did the window withdraw. So if I actually took this line out, so let me just quickly comment this line out. We're going to get this irritating weird TK window here, so to get rid of that we're just going to do this, which will make it invisible, and then we can only have this message display here. And then I did message box to show information. That thing takes in 3 parameters, so I just filled in 2 of them. So that's going to be the title, and we don't actually have to write this, it's going to work perfectly without actually writing this title right here, but I just made it to make it a bit more clear that these are the exact parameters we're passing into it. So the title is game over, so if you actually look right here, it says game over, and then it says score and 0. So this message box is actually a show info message box. We've got plenty of different message boxes. Okay, you just look up on Google, you can see all the different types. We've got error message boxes and a lot of other ones. So we got this title, which is going to be game over. Then the message is going to be an F string, so it's going to be score and self.score, which is going to be allowing us to pass it in. Now you could just turn this into a string or just concatenate it onto there, but I just find F strings are a lot more reliable in this sense. And then you don't actually have to have this one here. This essentially prints out the score in the console right here. I just thought it was a cool feature. This makes it a bit easier if guys wanted that feature, but you can take that line out, so it won't print out the score on the console. Then we have Pygame.quit, which will essentially stop Pygame and uninitialize all the modules, and then desist.exit, which will essentially just so if I actually remove this, so let me just quickly remove that. I'll save the file, then I'll run this. We're gonna get an error here saying display surface has not been quit, blah blah blah. Now by doing select.exit, we're not gonna get this error because the entire Python just ends the entire program once we run this program. So select.exit, the entire program's just shut down straight away. Nothing is left. We can't really get that error about the video system not being properly uninitialized, whatever it is. Next, I moved on to making my snake class. So in this snacks, as you can see, I inherited from the main class, and then in this this underscore init method, which is run as soon as we make an instance of the class or a child class makes an instance of the class. I'm inheriting all the attributes and methods from the underscore init class, and then from the drawGrid class, so I can access the self.drawGrid instance attribute inside of this drawGrid method. Okay, so I just passed in the parameters right here because I had to. Then these two right here is the start position X and start position Y for the snake, and this is going to be equal to the width of the screen, which is 600 divided by 2, and I put double forward slashes here so we only get a whole number as back. And then I also did +1. Now this may seem kind of strange, and it is pretty strange, but essentially it centers the snake inside of this square, because otherwise it will not do it. I'm not really sure why, but it just would not center properly, probably because it wasn't in the right position. But by doing this, the snake is centered properly, and yeah, it looks fine. Then I moved on to doing this part. So self.snakeLength. Now it's the snake length. So the way I actually made the snake longer is that I had a list which contained, so it was basically a list of lists which contained the snake's position, and then it will be updated every single frame. So every single time the screen was refreshed, this snake length list will be updated with new coordinates for the snake length. So whenever I touched a piece of food, it will essentially just draw the snake in the previous position that I was. So right now I was here, and then the previous position was there, and then each of the segments of the snake would do that, and then whenever I collide with the segments of the snake list, then it will just end the game. So we'll call this quit method right here. And then the snake length allowed, which will essentially just allow us to keep track of how long the snake's gonna get. So if I said it's something like, I said it's 0 at the start, so this will essentially, for some reason that did not work. That's a bit weird. Okay, that's, will it work now? Okay, so it'll make the snake start at a length of 0, which is essentially just 1 block, and then I'll keep on appending. So I'll just change the value of the length allowed every single time it touches the food, so it can grow every single time. Then I have these controls right here. This I'm not actually using, so you can actually just delete all of these, but I just kept this here as a reference when I was making the snake's controls work, so I actually knew where to change the X and Y coordinates. So you guys can actually just delete this, but I made these instance attributes before just like a reference to them. I should probably just use them instead, but yeah. You guys can delete this, or you can just use this instead of the ones I used for the main game loop when I was referencing it to it for the control in the controls section. So I'll show you guys that in a minute. So the draw snake function takes in a parameter called snake list, and then what happened was I didn't actually define snake list yet. It was actually defined later, so I believe it was defined somewhere. It was defined somewhere around here. So snake list is essentially it's actually snake length. So right here, I essentially just I didn't want to reference to directly, so I just put this as a parameter, and then I just self.block width is equal to self.mbox, which is essentially the width of every single segment which you're going to append onto the snake. And I did self.block width minus equal 1, so this is basically us drawing the snake, and then I set its positions to be minus equal to 1, so it actually fit properly on the screen. Then I did snake, made an instance attribute called snake head, and this essentially just holds in the values of the snake head at a given time. And I just set this, I just appended the values of start position X and start position Y. So the reason I did this was, so the snake head, every single frame, the snake length right here is going to be we're going to append the self.snake head. So whatever list we have inside of snake head, we're just going to append that list into snake length, which is going to be a history of all the different positions the snake has been in, and then every single time the snake touches the food, we're just going to draw the last segment from that which has been appended into the snake length. So I hope that made sense. So this start position X is going to be updated every single time because that's the actual position of the head of the snake. And then I put that into this head list, and then I just appended that onto the snake length. So whenever you get a new position, actually I'm just going to print out self.snake length. So just to show you guys. Okay. So as you can see, it just keeps track of all the different positions of the snake. The history of all the different positions of the snake. And this essentially allows me to make the snake longer or shorter. Then I did for X in snake list, and we're just drawing the snake, and this is basically going to be different coordinates for the snake list. And then I set it to be 20 by 20, sorry 21, it's going to be 19 by 19 pixels or something like that. I just set it to block width, so you guys can probably calculate what that's going to be. I believe that's going to be 19 or something. And then x0 and then x1, which is essentially the current coordinates of the snake. That's just is the current coordinates of the snake list. And yeah, then I did for Y in snake list, so this is basically the way that we're going to be checking if the snake has touched its body, and this is the way we actually check it. And let me just quickly fix the grammar here. Okay. So for Y in the snake list, and this colon basically allows us to do a list comprehension. So we're going to be searching for every single element in the list except for the last one. And then the reason we're not searching for the last one is because that's the current position of the head of the snake, because that's the most recent one we appended, and that's the current position of the head of the snake, as you can see. So yeah. So every single frame, as I update the screen, the last we're gonna append. So what append basically does, it adds that thing to the last part. It's gonna be the last. So append essentially adds an element into the list that's going to be at the end. So we're going to be searching that, so the last element's actually the real position of the head of the snake, and then if the head of the snake is actually going to so the snake is actually just a list of lists. So if Y is actually a list of X and Y coordinates, so if X and Y coordinates is going to be equal to the actual position of the head, so if the head of the snake touches any other part of the snake in the snake list, we're just going to call this function called self.quit, which will just stop the game. And then this thing I can actually just delete this thing off there, because that was just another way I was trying to figure out how I could get the position of the head of the snake. And this is boundaries, so I don't want to go into how this entire thing works. You guys can probably just figure out how it works, but I'm essentially just making it so that whenever the snake's head touches one of the edges of the game, it automatically just shuts down and displays the self.quit method. And then I made the food class, so we're inheriting all the stuff, and we're inheriting the snake class. Now, what I'm actually doing by adding snake here, I'm actually inheriting from the food is from the main class, and I'm also inheriting from the snake class. And the reason this is because the snake class is, as you can see, if I go all the way up here, the snake class is inheriting from main, and then what this is basically is multiple inheritance. So instead of having to define the parent all the parent classes we want, if our parent class has already inherited from another class, so if our parent class is a parent class, then we will inherit from both of those classes. And then here I'm just inheriting everything from the main classes underscore in it, and then I'm also inheriting everything else from the snakes in it. And that will allow me to access most of the instance attributes I want to use. Then that's accessing the straw snake, which I actually need some instance attributes from. And then I was also accessing the boundaries, so I'm going to be using these ones. Then I'm drawing the food. So here I was essentially just trying to get an X and Y. I was trying to get random X and Y coordinates for the food, which actually fit inside of the grid perfectly inside the square. And that took me kind of a while to figure out, but yeah, you can just read the code, you probably figure out how it works. So I use a random.randint. So if I got all the way up back here, we imported random, and this is the reason why. And so if I go down a bit more, randint, so you have to give it a starting value and an ending value. So I did 0 to self.width, and it's going to pick random values between the start of the screen and the end of the screen. I did that for thing 1 and thing 2, which is basically X and Y of the screen. And then I had to turn this into an integer, so what I did was I did 20 times by round. So what I did was I divided thing 1 by 20, and then I multiplied that by 20 again, which made sure I got a multiple of 20. The reason I wanted a multiple of 20 is because that's the actual size of the screen. So the size of the gap between each part of each square in the screen. And then I cast this into a int, and then I also added one so it'll perfectly fit inside a square. So if I delete these, I'm gonna have the same weird effect with the it looks like so essentially it didn't actually work before, but suddenly it decides to work now. But I added one to it so that will allow me to essentially it will basically make it so that it will spawn perfectly inside of one of the squares in the grid whenever it gets in the random location. So this part here, what I did was that I set the I don't think I actually, this part I don't really know, I can't remember what I did here, but it was something about I had this error when I was trying to set the value of random X and random. So random X and random Y is essentially what we're going to be using to be able to set the position, to randomize the position of the so the random X and random Y is the position of the food, and then I'm going to be setting that to thing 1 and thing 2 whenever we collide with whenever the snake collides with the food. But the thing is, I want to give a starting value of 21 pixels by 21 pixels, and that's the position it starts at. The problem I was having is that whenever I take out of this try and accept thing right here, what would happen is that so this is actually running inside of a while loop. So whenever I try to run this thing, it will set the value of the position of the food to be 21 pixels by 21 pixels. So it will go to a random location of the snake collided with it, but then it will rerun all this code because it's in a while loop, and then it will just go back to the position I specified at the start, which is not ideal. So what I did instead was that I did try and accept, so I was going to try to check if self-random X is equal to self-random Y. We're not going to do anything with that. And I got an attribute error, so if we've got an attribute error, I'm just going to set this as self-random X and self-random Y, because this is the first time we're running the method, and then I actually want to give the food class an actual position. So then I drew the food, which is basically taking the parameters, and the self.block width is used before. And then here I was making sure that the snake actually didn't infinitely keep on growing. So you saw that snake length allowed, that's basically the length of the snake. If I did not specify that, the snake would just keep on growing forever without touching the food. So I'm trying to check if the amount of elements, so this is actually going to be a list of lists, so the amount of lists inside of this list called snake length, if the number of elements inside of it, so every single time the snake length is actually updated, it's the snake is actually redrawn. So if this, I'm just checking if this is going, this snake length, the number of elements is greater than the number of rectangles this snake is allowed to get as long to. And if it is greater, then we want to pop off the first element, because the first element inside our list, because that's the oldest one. That kind of makes sense because we're appending, so it's going to the last part of the list. And then this basically makes it so that it will only it won't keep on infinitely growing unless we tell it to. And then we're just checking for a collision. So collide rect, since they're both rectangles, we don't actually have to draw a rectangle behind them because they are rectangles. And then we're just checking if those two collide, and if they do collide, we're gonna add 1 to the score, and then we're gonna set the random x variable, or the actual the food will actually randomly go around the entire map. So I'm just gonna turn the random x's to do that. So whenever we touch the snake touches the food, this food teleports to random location. And then I did the same for y, and then I changed the length allowed to 1. So whenever we draw, so right here in this statement, if statement right here, we're setting this length allowed to be 1, so it can actually grow up to being 2 squares long. And then if I set this length allowed to be 2 instead, and if I run this code, so instead of whenever the snake touches the food, it's actually just gonna get 2 segments longer, and now it's gonna get 4 segments longer. And I only want it to be I don't want it to work like that. I want it to be 1 segment every single time we touch the food, like the actual snake is. And then we have the game loop. So, oops, this was a bit of stuff from before. So while true, this is basically handling us quitting the game, and then this is handling the controls. So I don't want to go into this, but essentially we can press up, down, left, right keys to move around our key. So whenever we press those keys down, up, down, left, and right, the snake will move accordingly. And then also there's Q, so we can quit the game if we wanted to. Just press Q, then it will do that. Then key up is essentially allowing us to so in Snake, whenever we press the so whenever I only press the key once there, so up key, so it's gonna keep on moving. So if you press one key, we just want the snake to keep on moving in the position we told it before. So this key up means whatever key we just let go of. So key down handles the current key which we just pressed down, and key up handles the current key we just let go of. So it's going to keep on making move, and then if that key, depending on what that key is, it's going to run the exact same code, so it's going to make it move to the direction we tell it to. And then I'm also adding Q so that it will actually quit it properly. And then this is actually a main game loop. I know it's kind of weird of making this entire bring our main game loop into a class, but yeah, I want to try and make this entire thing object oriented. And then it's going to be running these following functions to draw the grid, and then it's going to be drawing the food, then drawing the snake, then drawing the boundaries. It's going to okay, so here I can just do self dot update, which will essentially run the update function. We could do food class, but yeah, it's better to do self. And then food class right here, make an instance of the food class, and we can access all the methods and instance attributes from the parent classes inside of this thing. So I'm just setting up the game screen. This is the actual I'm just setting the snake length, which is going to be set to an empty array at first. And then I'm going to set the game loop. So the reason I set this snake length outside of the game loop is because if I set it inside the game loop, it's going to keep on changing it back to an empty array, then we won't be able to make our snake longer. And then I'm just running this main function at the end. So as you can see, this entire thing was actually 210 lines of code if we take off the extra empty line. So it was not at all a long project. It actually just took me a few days to finish. It was a bit challenging because this is my first time actually making a game using Pygame, so it's pretty much foreign to me. I did dabble in it before, but not to that extent to actually build a proper game out. And I didn't follow any tutorials, so this is literally me just trying to understand the entire thing, looking at the documentation and trying to figure out how everything worked. So this video is really long. It's around 45 minutes right now. So I'm just going to end the video now. So if you guys actually did enjoy the video, and I would highly appreciate it if you guys left a like and subscribe to the channel. And if you guys do enjoy some of the content I uploaded, if you guys enjoyed this content, please leave a comment and I'll try to do more of these project reviews kind of. So I'll show you guys some of the projects I made. And then finally, if you guys did also enjoy this Python project, then I also I recommend you guys to look at the Python course I'm still doing, because it's kind of is a similar kind of explanation the way I'm doing it there as well. So I hope you enjoyed today's video, and that's it from me today, and goodbye. And also, the code is all going to be in the link below, and I'm going to leave a link to the GitHub repository in the description if you guys want to check out all the code. So, bye.